Archimedes' principle states that for a floating object, the weight of the water displaced equals the weight of the floating object. How does this relate to the buoyant force expression that is equal to the density of the fluid times g times the volume displaced? Well, we've already seen that that formula for the buoyant force really is expressing the weight of the water displaced, since the density of water, if water is the fluid, times volume displaced is really the mass of the water displaced, and times g becomes the weight of the water displaced. For an object that floats, though, so let me draw like a floating object here. Right? Maybe this is a boat or something. I never said my drawing is going to be good, right? And it's floating in some water here, right? So it's the volume of this part that's underneath the water that really represents the volume displaced, and it's the water that was displaced out of that volume. It's the weight of that water that is really equal to the buoyant force. But Archimedes' principle says that that is equal to the weight of the floating object. Well, I think we can relate that to a free body diagram by recognizing that the weight of the object is here, right? That's F sub g. And if this object remains floating and doesn't sink, and it doesn't take off into flight for some weird reason, then these two forces must be in balance. So the statement that the buoyant force is equal to the force of gravity is really equivalent to saying that the weight of the water displaced is equal to the weight of the object that is floating. So let's check that with the answer. It says for an object that floats, the free body diagram would consist of the object's weight and the buoyant force exactly balanced. That's what we said. Therefore, Fg is equal to Fb. I said Fb is equal to Fg, but close enough, right? And since that would mean that Fg, representing the weight, is equal to this formula we were given, which again represents the weight of the water displaced. So it's saying it a little bit differently here, but this says that the object's weight equals the weight of the water in the displaced volume, which is Archimedes' principle.